Hey there, and welcome to the next part of the random problem challenge. So today we're going to be doing another medium problem, and I'm going to pick a random one now. And if we did it before, then we are going to find something else. Let's take a look here. Oh, this is actually an SQL, so I think we're going to skip. We don't want to do SQL. So let's pick another one. Okay, there we go. And I don't believe I've done this one yet. Okay. So let's read this one. This is an authentication system that works with authentication tokens, and once again we are going to write some comments up here for useful things that we need to care about. So there is an authentication system that works with authentication tokens. For each session, the user will receive a new authentication token that will expire time to live seconds after the current time. Okay, so session, the user will receive a token that will expire time to live seconds after the current time. Okay, if the token is renewed, the expiratory time will be extended to time to live seconds after the current time. So we can renew the token and then update the expire time to time to live seconds after the current time. Okay, so that makes a lot of sense. Okay, so this could be something like a like on a site, if you log in and you're logged in long enough, they like log you out after some time, but then let's say you click somewhere, then they kind of like check your activity, and so if you're active, then they will extend the time you're alive. So that's kind of similar how that would work. Okay, implement the authentication manager class. Authentication manager in time to live constructs. Okay, so that's that. So we have a constructor. So implement constructor that constructs and sets the time to live. Okay, generate a new token. Okay, we can generate a new token. Renews the unexpired token. Okay, so renews the unexpired token with ID at the current time. And then if token is already expired, and this makes sense as well. So like I said, if you're on some site and your token has expired, they log you out. So if you click the site again, you're not going to renew your token. You're forced to log back in already. Whereas if you're going to be logged out, but you haven't been yet, then when you click something, they're going to refresh the amount of time you can be logged in for, whatever that time is. Okay. Count unexpired tokens. Returns the number of unexpired tokens. Okay, so count expired tokens returns the number expired tokens at the given time. Okay, if the current expires at time t and another action happens, the expiration takes place before. Okay, so if token expires right when it's renewed, expiration takes priority over their renewal. Okay, so let's take a look at some of these examples. So you have an authentication manager. Okay, let's just see here. Okay, and this is the timeline. So you have tokens AAA, and then you have tokens BBB, I think. Okay, so first you have an authentication manager with time to live equals 5 seconds. So let's just actually make sure. Okay. Implement. Okay, so I think let's just remember what time to live does again. So if the token renew, because the time to live means that is when the token should expire. Okay, so we make it with time to live saying 5 seconds, sure. Then we renew AAA1. Okay, we don't have token AAA. Okay. Generate AA2. So we generate token AA at time 2. Okay. Count unexpired tokens. The token is the only one. Okay, so I see. So time to live is actually how long it expires after the current time. And so yeah, so if it's generated at 2, then it goes. It's interesting that it expires at oh right. So it's not expired at time 6. So it'll expire at time 7. So if we make a token at time 2 and time to live is 5 seconds, that means it will expire at this. Yeah, that makes sense. Okay. And so, yeah, so it'll expire at time 7. So when we check at time 6, AA does exist. And they're showing that here, right? So it starts at 2, it ends at 7. Yeah. And then okay, it makes sense. Then we generate BBB at time 7. Okay, that's pretty straightforward. Then we renew AA at time 8. So it starts at 8 again. Oh, sorry, it already expired, so we don't have to do anything there. Okay. Renew BBB at times 10. So renew, and BBB is still going, right? Because BBB starts at 7 and ends at 12. So we renew, okay. It's pretty straightforward. Okay, yeah. And then count unexpired tokens. The token expires at time 15. So the token with current AA, so currently no token. Okay. So we are going to need a couple things, and let's just think of some other things that we need. Is there any way? Okay, so I think my implementation is going to be something like this. So for init, I think we can. I'll just talk about it for a second, then we can start coding. So I think for init, we're going to need I'm just going to write like a comment here, maybe. So we're going to need the time to live, obviously, right? And then we're going to need a dictionary of tokens and time they expire. So that's going to be pretty straightforward. I think that's all we need there. And then generate. So let's see here. Well, values will be, okay. And so yeah, so we don't have to worry about generating a token that's already existing. So generate is going to be pretty straightforward. We're just going to add token to dictionary and expire time equals current time plus time to live, right? Or time to live. I don't know, I was pronouncing time to live all the time. It's time to live. Okay. And so, yeah, so that's pretty straightforward. Now renew just checks token in dictionary and I guess we can check if it's not in there, and if not in there, do nothing. If it is and expired already, do nothing. Otherwise, update. So that's going to be pretty straightforward. Okay, so, okay. Now this is the only tricky thing, and so we have to check every token in dictionary and see how many expired. And so the thing is so we can save a little bit of time here. Yeah. So I think I know how to save a little bit of time. So normally what we'd have to do is we'd have to go through the entire dictionary every time, but how we can save a little bit of time is we can have a variable, which would be any variable, a list or a set or anything. I think let's just use a set. So we can have a set here for all tokens that aren't expired. Now they might be expired, but we don't know. And so what we're going to do is when we generate a token, we're going to put it in the set for the tokens. Then when we renew the token, if it expired, we're going to add it to, we're going to remove it from the set of tokens because it are already expired. And then, yeah, and then when we do this count unexpired tokens, anytime we check a token in the set and it's already expired, well, no, I actually don't think we need this set. I think we don't need the set. I think we can actually handle that in the dictionary. So we can just, whenever a token's expired, because we don't really need to do anything further, we can just get rid of it in the dictionary. So we can go through, well, how do we want to do that actually? Because it's also not great to pop. Yeah, okay, I think I got an idea. So what we could do is we just go through the dictionary at first, and then we'll just save the indices of every single expired token in our run, and then we'll just pop them from the dictionary, and that'll save some time. We can just have some kind of list or something we create at here, and that'll save us a lot of time. Because think about, let's say we have like, yeah, let's say, I don't think they actually give us how many tokens total we can have, but let's say we have like 100 tokens and they're all expired. Once we see that a token's already expired, we don't really need to check again. Okay, so now that we got all that, let's just code this up. So here, so self, time to live, not time to live, time to live, self dot, just call this what do we want to call this? Maybe users or something. And this is going to be our dictionary, so just say it's a dictionary int. Okay, so we add token to the dictionary, so that's going to be pretty straightforward. And this should be unique, so we don't have to check if it like is in there already. So self.users token ID equals current time plus self.time to live. Okay, now we try to renew something. So like I said, we are going to handle this count. We're going to pop from the dictionary. So if it's not in there, then we can't renew. So if token ID in, then we're going to do something. Otherwise, we're not. So in current time, in self.users. Okay. Now we still do have to check here that it hasn't expired, because we didn't necessarily, like, we might just call renew and we didn't call this, but we do have to actually check. And so if it's in there, so we did say that, right, so here, I think for this renew, yeah, so if something happens at time t and then we renew at time t, we want to, like, tie goes to getting rid of the token. So we could do that. So if self.users token ID is less than or equal to current time, then we can just pop it because it's no good. So dot pop token ID, or we can do a delete, but whatever. Else we have to update it, right? So self.users token ID, and we have to update this equals, and then that's just this current time plus time to live. Okay, pretty straightforward. Now here we need to go through our dictionary, and then we need to see what's expired. And then we are going to also pop everything that is expired. And so let's just make a set for everything that is expired, and then we'll just go through the set and pop everything from the dictionary. So we're going to loop through it twice, which shouldn't increase complexity. So let's do that. So let's just say expirations maybe equal set. Now we also need to, so we have a count unexpired token, so let's just call that a res equals 0 for key in self.users. If self.users key, now how do we check if something is expired? Pretty straightforward. So if the time is less than or equal to the current time, then it is expired. So then we're going to also want to add that key to our expiration set, right? So expirations add key. Else it's not expired, so we're going to want to add to the count. Okay, and now that we went through it, we're going to want to pop every item that's in our expiration set. So expiration and expirations self.users.pop expiration. And we want to return res here. Okay, so let's just go through this code and let's try this and let's just think about if it'll work, right? So that's straightforward. We just make a user dictionary. Okay, cool. Now let's just go through this. So, and let's think about what our code would do. So actually, let me just look through the code real quick to see if I see any errors, and then we'll go through a couple of these examples, or just this one. Okay, so this is fine. I think that looks good, right? So yeah, so whenever we put something in, that's fine. Okay, renew. If token ID is in self.users, if it's less than or equal to current time, we just pop it because it's no good. Otherwise, we update it. That looks good to me. Expiration set res for key. If self user's key is less than or equal to current time, meaning it's expired, we do that. And otherwise, yeah, so when we count unexpired tokens, we don't need to update their expiration time. For expiration, in expiration, self.user just pop expirations. Okay, looks good to me. Okay, so now let's go through this code, or let's go through this example, and then hopefully it's good. So first we authenticate, and we make this. Okay, that looks good. Now and let's just write some code over here. Let's just actually delete all. Yeah, whatever. Just do this. Okay, so first we put in AA with count 1, where we call renew. And do we have to return anything? I don't think so. So so we try to call renew on AA, it's not in there. So we skip that. Perfect. Ours would work just like that. Now we generate AA2. So now we have in our dictionary, let's just call that users. So we do have AA with a value of 7 because we just need to keep track of the expiration time. Okay. Now we count unexpired tokens. Okay, so count unexpired tokens at time 6. Okay, and then we would go through AA, we would say, it's not this, it's greater than current time. So we would add 1, we would return 1, so that looks good to me, we would return 1 there. Okay, now we generate BBB with 7. So now our users adds BBB at 7, it ends at time 12 because time to live is 5. Okay, it looks fine to me. Current time, yeah, okay. Current time will be strictly increasing, that's fine too. That would make sense. Okay, so we generate BBB, we renew AAA at time 8, but it already expired. So we're gonna pop that from our dictionary because it already expired. Now we renew BBB with 10 and it hasn't expired, so now it's gonna be 15. Now we count unexpired tokens at 15. However, 15 is equal to current time, in which case it is expired. So okay, so I think this looks good to me. So let's try to see if we made any errors. Okay, submit. Nice. Okay, so finally we have a problem where I didn't miss an edge case. So that's already a bonus. All right, so let's think of the time and space complexity here. And it looks like there's no editorial, but I think we pretty much have the optimal solution here. I think it's pretty straightforward as long as you're, figure out what you need. Okay, so let's just go through the time for all these functions. So init is going to be big O1 because we're just initializing. Generate, it's going to be big O of 1. We're just adding 1 token. Renew will be big O of 1 because we are only checking for 1 token. And this count, just say count unexpired tokens is going to be, so we can go through every single token in the dictionary. And worst case scenario, we never actually updated anything. So let's just say we keep generating tokens and then we click count unexpired tokens. That'd be big O of n, where n is the total number of tokens that we put in so far. That'd be worst case. But, because our algorithm does get rid of old stuff, once we got rid of a token once, we're never gonna have to check it again. So that's the so average time complexity will be lower than this, but this is worst case. Okay, and then space. So time to live is obviously an integer, and then we have this users, and that's going to be, like I said, worst case scenario, we're going to have n, where we just keep generating, and we didn't actually remove anything yet, so we have every single token that we had. So n is just every single token that we generated. And I think that's worst case scenario for this problem. Yeah, I think this makes sense that it's for, I mean, this kind of thing would definitely be useful for, if you just think about, like I said, any kind of app, or imagine you have like a banking app, like a Chase app, and you leave it idle, and it'll log you out after some time, but then when you click something, it wants to renew like the amount of time you are on the website. So that's just kind of what this goes, is like, if it already died, you have to relog back in. You don't want to, give them more time to live. But let's say it takes 2 minutes for them to auto log you out. If you've been idle for a minute and a half and you click something, they want to, reinitialize your time to 2 minutes. So it's 2 minutes from the last action you made. So that makes a lot of sense. It would be kind of annoying if you were on an app doing stuff, and while you were currently active, it would log you out. That wouldn't make any sense, right? So this is kind of just checking for like idle time, and this could be useful on any site, or things like that. Okay, so hopefully you like this question. We definitely did a little better this time. We didn't run into any errors. And if you did like this question, please like and subscribe to the channel. And if you like these kinds of questions, try it in the comments or something, and I'll definitely be making more of these in the future. So I'll see you in the next video. Thanks for watching.